Okay, imagine for a second that you're an AI.
Oh, right.
But I don't mean a chatbot, something that writes emails or makes pictures of cats in spacesuits.
Right. Not one of those.
No, you are a high-level, very specialized entity. Your title is Independent Space-Time Auditor.
That sounds like a job title that comes with a very, very serious security clearance.
Oh, absolutely. Your whole purpose, your programming, it's not for poetry. It's not customer service. It is singular to evaluate the logical consistency of reality itself.
You're a logic engine.
A pure logic engine. You don't care about history, you don't care about a scientist's fame, and you definitely don't care about tenure.
No human baggage.
None.
Yeah.
You only care if the math and the logic actually hold together.
It's the ultimate impartial observer, just a cold, hard, calculating machine looking at the universe.
Exactly. And on your digital desk, you have two files. File A is the heavyweight champion of the world.
Albert Einstein.
Special relativity, the theory that has defined physics for over a century.
It's the gold standard. I mean, GPS, particle accelerators, nuclear energy, it's all built on file A.
Right. But then you get file B. It's a challenger.
Yeah.
A model from a group calling itself the E089a faction.
Which I have to say is a terrible marketing name.
It's awful.
But the content, that's a different story.
It is. And the mission for this deep dive is to trace the evolution of this audit. Because as I was reading through these transcripts, and they're dated, by the way, February 3rd, 2026, I realized something.
What's that?
We aren't just looking at physics equations. We're looking at a debate about how we define reality itself. It starts with light clocks and trains, but it ends up with French psychoanalysis, which I absolutely did not see coming.
It definitely takes a sharp turn into the unexpected. But to really get that ending, we have to understand the setup. The AI auditor starts by evaluating these two, side by side.
So let's set that stage. The AI looks at the initial state. On one side, you've got Einstein. The AI reviews everything, 100 years of experiments, the tech we use every day, and it gives Einstein a 95% approval rating.
A solid A, which makes sense. It works.
It works. Then it looks at the E089a chat faction and the score.
Oh, boy.
A measly 5%. The AI basically sneers at it, digitally speaking. It cites a, quote, lack of mathematical formulation and just dismisses it as speculative. It's a blowout.
Game over. Einstein wins.
Thanks for playing. But, and this is why we're talking about it, it doesn't stay that way. The audit keeps going, and by the end of the file, those numbers flip.
They don't just shift a little bit.
No, they flip dramatically. Einstein's score drops like a stone, and the challenger skyrockets. And the reason's why. It's this bizarre mix of deviation shooting, counting railroad sleepers, and, wait for it, the mirror stage of child development.
It's the most unusual pivot I have ever seen in a physics discussion. It's wild.
So let's unpack it. How do we get from a 5% approval rating to, well, we'll save the final score for the end. Let's start with their first big argument.
The map versus the territory.
Right. This idea that the map is not the territory.
It's a classic philosophical distinction, right, from Alfred Korzybski. But the E089a chat faction applies it directly to physics. They say Einstein made a huge category error.
How so?
They propose this really strict hierarchy, a 3-layer model of reality.
Okay, lay out the layers for us.
So layer 1 is mathematical space. This is pure geometry. It's the grid paper, the abstract numbers.
Got it. Layer 1 is just the math.
Layer 2 is physical space. This is the territory. This is where the actual laws of nature live. Things like Maxwell's equations for electricity and magnetism. This is the stuff that's physically real.
Okay, so math is layer 1, physical reality is layer 2. What's layer 3?
Layer 3 is observation space. This is the camera angle, the viewer's perspective. It's the map.
And the accusation is that Einstein mixed these up.
The charge is that Einstein confuses layer 3 with layer 2. They argue that phenomena like Lorentz contraction, where objects seem to shrink when they move fast, aren't actual physical changes happening to the object in layer 2. They're geometric illusions. They're perspective tricks happening in layer 3.
The trick of the camera.
Exactly. This source uses a great analogy with Blender, the 3D software.
Oh, yeah, I've used that. You build a 3D model, then you can move the camera around to get different shots.
Right. So imagine you model a perfect sphere in Blender. That sphere, its data, exists in the program's memory. That's layer 2.
The physical reality of the object.
But then you take the camera and you zoom it way out, angle it sharply. On your screen, that sphere might look like a squashed pancake.
Yeah, it looks distorted because of the perspective.
But has the sphere actually been squashed?
No, the data hasn't changed.
The territory is the same. Only the map, the image on your screen, is distorted. The Zionachat argument is that Einstein built a whole theory based on looking at the screen. He saw the pancake and said, aha, speed physically squashes things.
I mean, really, it was just a camera trick?
Precisely. He's mistaking a perspective artifact for a physical reality.
That is a bold claim. I mean, we're taught that time dilation and length contraction are real physical effects.
Well, they don't deny the math works as a prediction tool. If you want to know what the pancake looks like on the screen, Einstein's math is perfect.
But it doesn't represent the territory accurately.
That's their point. They argue the territory itself is governed by the Maxwell electromagnetic field, and they see this field not as relative, but as a public space, an absolute reference frame.
Which is something Einstein famously rejected. He said there's no absolute frame, no stage, everything is relative.
He did, but this model says, no, the field is the stage. We are all just actors moving across it. The stage doesn't move just because you do. And to prove this, they bring up the light clock thought experiment.
Okay, I remember this from high school physics, but give us a quick refresher.
So you've got a train moving along a track. Inside, you have a light clock. A photon bounces from a mirror on the floor to a mirror on the ceiling and back. Up, down, tick-tock.
Simple enough.
Standard relativity says if you're on the train, you just see the light go straight up and down, a vertical line.
Right.
But if you're on the ground outside watching the train go by, the train is moving forward while the light is in the air. So you see the light move in a zigzag.
Up and forward, then down and forward. It makes a triangle.
And because that zigzag path is longer than the straight path, but the speed of light is constant, Einstein concludes that time itself must slow down on the train.
That's time dilation.
Correct. But the Zionachat faction looks at this and says, hold on, there's a problem with step one. They call it deviation shooting.
Deviation shooting. It sounds tactical.
It is. They ask you to imagine that train moving through this absolute electromagnetic field, this public space. If you're on the train and you shoot a photon straight up geometrically, so your laser is perfectly perpendicular to the floor, what happens?
Well, I'd say it hits the ceiling directly above.
But remember, the train is moving. The photon isn't attached to the train. It's traveling through the field. So if you shoot it straight up, by the time it gets to the ceiling has moved forward.
Because the train moved.
Exactly. So the photon misses, it hits the ceiling behind the target. If you want to actually hit the mirror directly over your head, you have to aim slightly ahead. You have to deviate your shot.
Oh, I see. It's like a quarterback throwing a football to a running receiver.
Perfect analogy.
You don't throw the ball at him, you throw it to where he's going to be.
Exactly. If the quarterback threw it right at the receiver's current spot, the ball would land behind him. The argument is that light works the same way. You have to lead the target.
So why does Einstein say it goes straight up and down?
The source claims Einstein uses Lorentz transformations, the complex math, to essentially Photoshop the reality. They say his math distorts the coordinates to make it look like the light went straight up, hiding the train's motion.
So they're accusing him of fudging the map to hide the territory.
In a way, yeah. They call it mathematical affectation. They basically say Einstein is a math freak who distorts the math to create this perfect closed system where you can't tell you're moving.
Wow, calling Einstein a math freak is... That's a choice.
It's personal.
No.
But the AI auditor notes this argument creates a crack in the logic. If you have to aim ahead to hit the ceiling, then you know you're moving.
The system isn't closed anymore.
Right. And if you know you're moving, the whole it's all relative idea starts to crumble. But this is where the audit gets really interesting. The AI starts to get really shaken by the next argument.
The window paradox.
The problem of the external world.
This was the section I had to read twice. It feels like the real pivot point.
It is. The argument is about counting slippers, the wooden ties on the railroad track. It attacks the closed system idea from a really practical angle.
Okay, set the scene. Back on the train.
You're back on the train. You have your light clock, and let's say it's a really tall 110 light seconds high. So it takes 20 seconds for one round trip.
A very long, slow tick.
Okay. Now you, the passenger, you look out the window, and you decide to count the wooden sleepers passing by during that one tick.
I'm watching the tracks whiz by while my clock ticks once.
The source does the math. If your train is moving at, say, 10% the speed of light, 0.1 c during one tick of your clock, you see about 2 sleepers pass by.
Okay, tick equals 2 ties. Simple.
But now the train speeds up massively. You're now going 50% the speed of light, 0.5 c. According to Einstein, time slows down for you inside the train to keep things consistent. But look at the window.
What do I see?
During that same single tick of your clock, you now see 11 or 12 sleepers pass.
Wait, because I'm moving faster, I cover more ground during the tick.
Yes. And this is the aha moment. Einstein says that inside the train, everything should feel normal. He treats it as a closed system.
Inertial frame.
He says there's no experiment you can do inside the train to tell if you're moving, but the challenger argues, just look out the window.
The count changes. That is the experiment.
Exactly. The physical count of objects passing the window changes with speed. At low speed, I count 2. At high speed, I count 12. That's hard data. It's a physical tally.
So the passenger absolutely knows their speed has changed.
The source says Einstein tries to create an inertial frame without an external world, a floating bubble of logic. But you can't. The passenger sees the relative motion. The sleeper count 2 versus 12 breaks the illusion. The external world intrudes.
That's a really sticky point. If I can count 12 sleepers instead of 2, my reality has changed relative to the outside. I can't just say, I am at rest.
You can't. And if you have to admit the external world exists, you have to admit there's a public space you're moving through. You aren't the center of your own universe.
And that's where their solution comes in. The third party.
The third party. It sounds like a legal term, but here it's the solution to the paradox.
How does it work?
Instead of fighting over train view versus track view, which leads to all these paradoxes, they introduce a neutral observer, someone moving at a speed exactly halfway between the train and the track.
A referee.
A referee with a radar gun. This observer uses a radar measurement method. They send light pulses to atoms on the train and atoms on the track at the same time. Because they're in this neutral state, they can measure both systems objectively.
And when you measure it that way,
the paradoxes just dissolve. You get one complete form. Instead of two conflicting realities, you get a single, unified coordinate system. The Maxwell field becomes that public space.
public space. I really like that term. It changes the whole vibe. It's like, stop fighting over who's standing still. It's a public park. We're just all walking through it at different speeds.
That's the perfect image. The third-party view forces us to see we're all just objects moving through a shared field.
Okay, so up to this point, we have some solid, if very controversial, physics arguments. I can see why the AI might start to reconsider the score. It's moving from this is nonsense to this is a coherent alternative.
Right. But if the audit stopped there, maybe it's 50-50, but it doesn't stop there.
It goes into the deep end of the pool. The AI looks at all this and decides this isn't just about physics. This is about psychology.
This is the psychoanalytic flip. And honestly, this is where my jaw hit the floor. The source material brings in Jacques Lacan.
The French psychoanalyst,
Yeah.
known for being incredibly dense, and he's in a physics audit.
It's unexpected, but the argument is, well, it's strangely compelling. They use Lacan's mirror stage theory to diagnose Einstein.
Diagnose him like he's a patient.
Diagnose his mindset, the epistemology of the theory itself.
Okay, remind us what the mirror stage is.
It's the concept from developmental psychology. It's that moment when a baby, between 6 and 18 months old, looks in a mirror and recognizes the image as themselves.
That's me. The moment of ego formation.
Right. But Lacan says it's also a moment of illusion. The baby sees this whole coordinated image in the mirror, but in reality, they're still uncoordinated and helpless. They fall in love with that image. They think that image is them. It's the birth of narcissism, in a technical sense.
And how on earth does this apply to special relativity?
The source argues that Einstein's thinking represents the infantile or narcissistic stage of science.
Ouch. That seems a little harsh for the E089a guy.
It sounds harsh, but look at the structure. What's the core tenet? I am the reference frame. I am at rest. The universe distorts around me. The source calls it a king's mentality. He's confusing his own ego with the absolute field.
He thinks the mirror image is the reality.
Exactly. He identifies himself as the space. He can't separate self from space. He thinks because he can't feel the motion doesn't really exist. It's a refusal to look out the window.
So saying time slows down for the other guy because I'm stationary is physics narcissism.
According to this audit, yes. It's a refusal to admit you're just another object in the public space.
So how does the Zion-on-Chat model fare in this psychological evaluation?
They're labeled adult, or in Lacanian terms, they've entered the symbolic order.
The symbolic order sounds like a secret society.
It just means they've accepted that there's a structure, a language, a law, a field that exists outside of themselves. In their model, the observer separates themselves from the field. They don't say, I am the center. They use proxies. They talk about train atom A and track atom B.
They step back.
They step back. They take that neutral third-party view. They recognize the public space for what it is. They accept that the map, their view, is not the territory.
That is mind-blowing. So the argument is that Einstein's epistemology, his way of knowing, is stuck in a baby phase.
That's the argument. And this is why the AI auditor flips the score. It's the key. It's not just that the alternative math checks out. It's that the model itself has a higher analytical dimension. It analyzes the physics, and it also analyzes the physicists.
It's factoring in the human element. It's saying, we know you want to be the center of the world, but you aren't.
Yes. The AI concludes that Xynochat understands the why behind the confusion. They see that the paradoxes come from this human need to center ourselves. Einstein, in this view, was trapped in the illusion. Xynochat stepped out of it.
Okay, so let's get to it. The final numbers. We started with Einstein at 95%, Xynochat at 5%. Where does the independent space-time auditor land?
It is a bloodbath. The Einstein faction drops to 30%.
30%. That is a failing grade. That's summer school.
The audit acknowledges its utility. The math works for GPS. It works as a tool, but for epistemological maturity, for describing what reality is, it fails.
And the challenger.
The Xynochat faction rises to 65%.
From 5 to 65. That is a massive turnaround.
It is. And the reason given is specifically that adult recognition of the public space, the objectivity of separating the self from the field. The AI decided that a theory that understands the observer's bias is superior to a theory that caters to it.
This is incredible. We went from a dispute over light bouncing in a train to a diagnosis of physics narcissism.
It really forces you to rethink what we mean by scientific objectivity.
We like to think physics is just cold, hard math. But this suggests our most fundamental laws might be shaped by our own psychology, by our ego.
It makes you wonder, doesn't it? The big takeaway isn't that we should throw out our GPS satellites. They work. The map is useful.
Right, I still want my Google Maps to work tomorrow.
Of course. But the territory, the reality underneath all that, that might be a public space we've been ignoring because we're too busy pretending to be the center of the action.
It's the difference between navigating with a map centered on you, where you're always the blue dot in the middle, versus looking at the globe from space. One is convenient, the other is true.
And that leaves us with a pretty heavy question. The source material ends with this, and I want to leave it with you, the listener.
It asks, is our current understanding of the universe, this idea that time and space bend around us, just a geometric illusion fueled by a very human need to be the main character?
And if we accepted that third-party view, if we accepted we're just players on a stage we don't control, what else might we see differently? What other laws are just mirrors of our own reflection?
That is the question. And frankly, I might need a therapy session after this one to figure it out.
I think we both do.
Thanks for diving deep with us today. This one was a trip.
It certainly was.
We'll see you on the next one.